Hey everybody, hope you guys are doing well. This lesson is going from general form of a conic section into standard form. So at the beginning of our unit, we graphed everything in standard form. And in the previous lesson, we just looked at general form of the conics and then we're able to classify circle, hyperbola, parabola, and ellipse. This lesson is going to take a little bit. It might be in a couple of parts, so stick with me. Rewind, pause, repeat, whatever you got to do to make sure that you get it. Let's get going. All right, so remember, the general form of our conic sections is ax squared plus bxy plus cy squared plus dx plus ey plus f, all set equal to 0. And the standard form of all of our conics, the circle is the first one. That's x minus h quantity squared plus y minus k quantity squared equals the radius squared. Then we have two setups, or we have the ellipse, and then we have the two setups for the hyperbola. For the ellipse, which is in the navy blue on the right, that's x minus h quantity squared over a squared plus y minus k quantity squared over b squared, all equal to 1. And depending on the denominator, depends on whether it's going to be a horizontal ellipse or a vertical ellipse. So whichever one's the bigger one shows you which way it's going. The next two are going to be the hyperbola formulas. And remember, if the x squared term is positive, typically it's first, but it doesn't have to be. If that x minus h quantity squared is positive, then that's going to be horizontal. If the y minus k squared is positive, then that's going to be a vertical one. And then the last one that we have is the parabola. If it's an x minus h, again, it's a horizontal parabola. If it's a y minus k, then that is the vertical one. All right, so here we go. Let's plug and chug along. All right, so we've got steps to convert. So we're going from that ax squared, we're not going to have the bxy term, but ax squared plus cy squared and so forth into the specific circle, ellipse, hyperbola, parabola formulas. The first thing that we need to do is get it set up. In other words, get all the x terms together, get all the y terms together, and if there is a constant, you move the constant value to the other side of the equation, because we have to complete the square for each of these. We want to make the x's a perfect square trinomial and the y's a perfect square trinomial. Now we're going to dig back in our brains from Algebra 1 and Algebra 2 to review this content. Next, we're going to check for the leading coefficients of the x squared and y squared terms. If there's anything other than a coefficient of 1 for x squared or y squared, you've got to factor it out of those x and y groups. Alrighty? Next step, complete the square. So this is going to make more sense as we go through, and I'll kind of walk you through piece by piece again as we hit each of the examples. In order to complete the square to make a perfect square trinomial, we're going to take half of the middle number and we're going to square it. We will then add that to both sides of the equation, in with the x's, and then to the other side of the equation with the constant value. Then we'll do it again for the y's as needed, and then we would add it to the y terms and then add that to the other side of the equation as well. After we get the square completed, our next step is clean it up. Okay, so get your trinomials in factored form, and then combine all the constants on the other side of the equation. For circles, you're pretty much done. For ellipses and hyperbolas, you need to make sure that whatever that constant value is, you divide through every single term by that constant, because those equations have to be set equal to 1. And then at the end, just double, triple check, make sure that equation is balanced. If you did something to the left, you got to do it to the right. Distribute values as necessary. Make sure you've combined all your like terms and all that good stuff. So we're 5 minutes in, we haven't done a problem yet. Stick with me. Like I said, it's going to be a little bit lengthy, but we go slow, we take it piece by piece, make sure we get it down pat. Here's our first one. Okay, convert the general equation into standard form. Okay, well, I want to first classify it. it doesn't ask us to, but we're just gonna, so we know what we're looking at, okay? So I have an x squared plus a y squared. My a value is 1 and my c value is 1. So if those are the same, they're equal values, that's exactly right. It's a circle, okay? So we know what the circle equation should look like. X minus h squared plus y minus k squared is the radius squared. All right. So after, take all that stuff, jot it down, make sure you got it before you process through the whole thing. Take it piece by piece. So our next part says, group your x's and your y's. So I'm going to group the x squared with the negative 4x, the y squared with the positive 6y, and then move that constant value, in this case our positive 4, it gets subtracted to the other side of the equation. Now if you'll notice, I do have space in between the x squared minus 4x, there's a space, and then the y squared plus 6y, and then there's another space. So we're going to complete the square to make those perfect square trinomials. And again, add those, whatever I add to the left, I got to add to the right. Do everything on each side of the equation. So if I add a value on the left, it gets added to the right. Okay, so to complete the square, it says take half of the linear term, that middle term, the negative 4x, half of that coefficient, half of negative 4 is going to give me negative 2, and then square it. Negative 2 squared is 4. And then the next thing I'm going to do is I'm going to add that value right here behind all the x terms. I'll also add it to the other side of the equation. Okay, that's our x's. The next thing we're going to do is complete the square with the y's as well. So we're going to take half of the linear term, the 6y. Half of 6 is 3. 3 squared is 9. So to complete the square for the trinomial for the y's, I'll add 9. And then I'll add 9 to the other side of the equation. You're going to see each of those steps in the next part. So here we go. X squared minus 4x plus 4. Y squared plus 6y plus 9. And then I have the negative 4 plus 4 from completing the square with the x's, and plus the 9 completing the square with the y's. So I have each of those in there. Okay, completing the square is done. That's technically what we would say is the hard part. It's not hard, it's a lot of little things to remember. All right, now, that's right, we got a factor. Well, there's a shortcut. When you take half of that middle term, the negative 4x and that positive 6y, half of it gives you the back end of your factor. So x squared minus 4x plus 4 is going to give me a factor of x minus 2 quantity squared. And we see that 2 from the half come right up here to be that 2 in the parentheses with the x. And then y squared plus 6y plus 9, that half of 6 gives me 3. That 3 becomes the back end of the factor for the y plus 3 quantity squared. Clean up everything, all those constants. Negative 4 plus 4 is 0, plus 9 gives me 9. Cool. Now, we know this is right, not only because we walked through it together and we know, but we said from the very beginning that this is going to be a circle. And we got the equation of a circle. X minus h squared plus y plus k squared all equals your radius squared. Good job. All right, that is that first one. Let's progress on, see how we do. There's our circle equation. Great, here's our next example. Again, going from general form to standard form, and we are going to take a moment at the beginning and go ahead and classify this conic section so we know what we're working with and what the equation should look like when we get to the end. So we have 9x squared plus 4y squared plus 54x plus 8y plus 49 is 0. So when we classify, look at the leading coefficient, the a, in front of the x squared, and look at the c, that coefficient in front of the y squared term, and compare them. Both of them are positive, so that means it would be an ellipse or a circle. They are not the same, so they're not a circle, which means we have an ellipse. And the other cheat that I gave you guys the other day was that multiplying a and c, if they're not equal, when you multiply them, you get a positive, that'll give you an ellipse. So we know what the formula should look like. A minus x quantity squared over a squared plus y minus k quantity squared over b squared all equals 1. All right, let's continue on. Here we go. First things first, group the x terms, group the y terms, and move that constant to the other side of the equation. Okay, there we go. Again, you'll notice we've left the blank in between, left some space for completing the square for the x terms and for the y terms. The difference with this example and the previous one, the circle had a coefficient of 1 for the x squared and the y squared. But now we have a coefficient of 9 for the x squared, which we have to factor out, and a coefficient of 4 for the y squared, which again we have to factor out. So in order to complete the square, you can't have a coefficient other than 1. Again, we're only factoring out the 9 and the 4. So here we go, factor out the 9. That'll give me 9 multiplied by x squared plus 6x plus, there's my blank. And then factor out the 4 for the y terms. 4 multiplied by the quantity of y squared plus 2y plus its blank. And then on the other side of our equation, we are going to add those values to complete the square along with their multipliers, because it's 9 times that whole quantity and 4 multiplied by this entire y quantity. Okay, let me show you what I mean. So completing the square for the x's, and this is up here in the top right hand side. So half of 6 is 3, 3 squared is 9, which means I'm going to add 9 to both. I'm going to put a 9 in for completing the square here. It's going to get multiplied by the other 9. All right, let's do the y's. Half of 2 is going to give me 1. 1 squared is 1. So I'm going to put a 1 to complete the square here, but multiply it by 4 when I add it over. Here we go. So again, we completed the x terms. We completed that square with a 9, but it's 9 multiplied by 9 added to the other side. There's a coefficient out front, so you've got to multiply through, you've got to distribute. And then when we do our y's, it's completing the square with a 1, but it's 4 multiplied by the 1 added to both sides. Okay, so that's the extra part you got to be careful of. Don't forget that. It'll mess up the whole equation and you'll go, oh my gosh, it's wrong. Well, it is wrong. You got to go back and fix it. Okay, so we're still going to go ahead and factor. Remember, when we take half of that middle term, 3 for the x, and half of this middle term, the 1 for the y's, that's going to give us the back end of our factors. So the coefficient stays 9 multiplied by the quantity of x plus 3 squared, and then the 4 multiplied by the quantity of y plus 1 squared. And off to the side, you'll see I've combined negative 49 plus 9 times 9, which is 81, plus 4 times 1. All of that together makes the entire equation equal to 36. Great. Okay, now we know it's an ellipse. We said so from the very beginning. A times C gives me a positive value. So that means the entire equation has to get divided through by the constant, 36, to make it all equal to 1. So there's my step of showing division of every single term, okay? And then here's the kicker, guys. These should, like, the 9 and the 36 are going to reduce. The 4 and the 36 are going to reduce. And then 36 over itself is going to give me 1. Yay! So we're going to get the quantity of x plus 3 squared over 4 plus the quantity of y plus 1 squared over 9, all equal to 1. And that is the equation of our ellipse for this example. That's a great job. That's a lot of work. Proud of you guys. We're at the 14-minute mark, so I'm going to stop the video for after these first two. We've got 2 more to do, a hyperbola and a parabola. See you in a little bit.